Hi Pre-Calc, this is Professor Wieland. I hope your test 2 went excellent, and I hope that you're doing as good as possible through these monumental changes. Please be kind to yourself. I know it can sometimes be challenging to do something that, you know, would usually take 5 minutes, can sometimes take a lot longer. So just please be kind to yourself. How we're going to run the course for the rest of the semester, I've made a decision on how I can best help you, and what I've decided that I can do best is videotape the lectures. I did take into account a couple ways to do this, and I've decided that this is how I can help best at this moment. So from now on, all your lectures will be videotaped and uploaded to Moodle. And when you have questions on the homework, I want you to do two things. You can use me as a support, and I also want you to use the online tutoring as support. If I receive a lot of questions, I just won't be able to answer them all, because to videotape them is very time consuming. So please use both resources, the online tutoring as well as me, to shoot questions. I'm just trying to get used to going through an enormous amount of email, so we're just going to have to navigate this the best we can. Okay, I hope that sort of makes things clear. The rest of your exams, you still have test 3 and a final exam. They will all be take home. That is really the silver lining on this quarantine. So, and you will get the 24 hours. Okay, gang. So let's just rock and roll. I'm now a filmmaker, and this is this is how this is gonna go. So we'll all just do our best. So please be patient with me. If you didn't know, I'm actually not a professional filmmaker, and I will occasionally, my hand will be off of the screen because I've forgotten to move the camera. So just please be patient with me as I try to start my Hollywood career here. And really the only thing that will be famous is my hand and the piece of paper. All right, so here we go. I'm going to pick up now with lecture 4.4, and we're going to find trigonometric functions of any angle. This is a really important definition. There's a lot of things hidden in here that you need to sort of focus in on, okay? So the reference angle is what we're going to focus in on, how to find it. Its significance is that it's going to let us calculate in our head, without a calculator, in our head, certain standard angles that go around the circle. So this is sort of a tool that's going to let you solve for angles on the entire rotation of the circle, certain standard angles that are based on 30, 45, 60, and quadrantal angles. All right, so this is the definition of a reference angle. It's, first of all, if theta is in standard position. Okay, standard position means you're starting at the positive side of the x-axis. Its reference angle is an acute angle. Okay, that's the first really important thing we're hitting here. Do you know what acute means? Acute means less than 90. Okay, so the reference angle is less than or equal to 90 degrees. Theta prime, that is how you signify it's a reference angle. This is called, the name of this is called theta prime. Then the reference angle, called theta prime, is formed by the terminal side of theta, okay? The terminal side of the original angle. So that means where the original angle stopped. That's the terminal side where the original angle stopped, and the horizontal x-axis. That is critical. This will be the part that will knock you off initially. Make sure when you draw theta prime, or the reference angle, that you are connected to the horizontal axis. You are never, never, never connected to the vertical axis. Never. It is the horizontal axis that you want to connect to. Okay, so I'm going to give you some generic rules, and these are generic, meaning that if you're wrapped more than once in a positive or negative direction, then it will refocus the camera if it does that. So don't worry, I'll fix it if that happens. So basically what I'm saying is these are general rules, and if you're wrapped positively or negatively more than once, these rules fall apart. You have to sort of think through them and calculate them otherwise. Actually, even if it's just negative, it doesn't have to be wrapped more than twice. So these are just basic concepts to how to find theta prime. All right, so let's start. You have to know for each quadrant. So in quadrant 1, if this is my angle theta right here, then in this quadrant, this is already acute, and this is the standard position. This is your horizontal axis that we talked about. This is the terminal side. So in quadrant 1, your reference angle actually is the same thing as your initial angle. They are equivalent because it's already acute. The reference angle is already in standard. It's already connected to the x-axis. Sorry, let me say this better. It's already acute. It's already connected to the horizontal axis. So it's already satisfying. It's got the it's acute angle, and the terminal and the horizontal axis are already part of it. Okay, so now when you rotate to quadrant 2, that means now that your initial angle is rotating over here to quadrant 2. So now this is theta. This is theta. So the reference angle has to be, okay, this is important. The reference angle is always the terminal side. So find your terminal side to the horizontal axis. It is an acute angle. So here is actually in quadrant 2, if you fall in quadrant 2, this is actually theta prime, right there. Now, how do you calculate theta prime? How would you find this? How would you crunch out what theta prime is? If all the way to here is pi, then how would we make the equation? How would we calculate it? In radians, we would say the calculation of theta prime would be, we didn't quite make it to pi. If we took pi and we subtracted off, so if all the way to here is pi, and we subtracted off this part, we would get left with this part. So if we think of going all the way to pi, but we take away this segment, God, I love the way my filming skills are so awesome. If we take away this part, then that leaves us with that part. See if you understand that. And be able to do it in degrees as well, right? You have to be able to be in both units. You could do 180 degrees minus theta if you're in degrees. Okay, next one. If we are in quadrant 3, the original angle, ooh, I'm going to get hired by Hollywood here. If the original angle goes into quadrant 3, like that, this is the original angle. This whole thing is the original angle. How you always find theta prime, go first find your terminal side, which is right here, and then go to the horizontal. So you're always either going to go down from the terminal side or up from the terminal side, but always start at the terminal side and find your horizontal axis. So right here is theta prime. It's always going to sit in between the x-axis, not in standard position. Not in standard position. It's always going to sit between the x-axis and the terminal side, wherever that might fall, in whatever quadrant. Okay, so now let's try to figure out what the equation to calculate theta prime in this quadrant might be. Okay, so how might we find it? This is theta prime. How might we calculate it? Any thoughts? If you notice, this angle here, theta, is bigger than pi. This angle theta is bigger than pi. And we want to take away all this stuff So I can just have this little leftover piece. I want to take away all this so I can just calculate this piece. So hopefully you see it. It's going to be theta, which is this whole thing. If I take away this, which is pi, so if theta is the whole thing, I take away this leaves me with just this segment. So that would be the equation. And again, if you're in degrees, the formula is this. And again, these formulas only work if you're in standard position, rotating counterclockwise. They do not work if you're rotating clockwise or you're wrapped more than once counterclockwise. So I want you just to get the general concepts of what I'm saying. All right, the last quadrant, and then I'll end the video here and I'll start another video. So I'll break the lecture up into different videos. Okay, last part of this particular video. So now let's rotate from standard position into quadrant 4, which is here. So this whole thing is one angle. This whole thing is your angle, your initial angle. Okay, so it could be like 300 degrees, right? It's rotating into the third quadrant. The theta prime is always from the terminal side to the horizontal in that quadrant. Okay, so it's right here. Here's your horizontal, here's your terminal side. So theta prime has to be sitting right in there. And you've got to figure out, how do you calculate that acute angle? So think about it for a moment. This here, I know we started at 0, but if you go all the way around, then it's 2 pi. If you go all the way around, oh, we lost the lighting, but I guess it's still okay. All right, so theta prime if this whole thing is 2 pi, but you take away all of this from the 2 pi, you're left with what we want. So if this whole thing, not my angle, if this whole thing is 2 pi, a whole revolution, if I take away my angle that I just drew, that leaves me with this. So the idea for this one, if you're in quadrant 4, is you want to think of 2 pi minus the angle. So take all of 2 pi minus the original angle. You'll be left with the red part. And again, if you're in degrees, it's going to be 2 pi. So, woohoo, yep. Theta prime is going to be equal to 360 degrees minus theta. Okay? So those are the formulas for each quadrant. And now let me say this one more time because I think you'll hear it better now. You're going to start with some particular angle. Its reference angle is an acute angle, less than 90, that is formed by the terminal side of your original angle and the horizontal axis of whatever quadrant you're in. Okay? Always the horizontal. Okay, gang, that is video number 1 for lecture number 1. There are more videos on the way. I hope you enjoyed this first bit. I'll catch you again soon. Bye-bye.